working on surface areas. And so everything we've done up until now, it has to do everything with area formulas. And so surface area is just finding all the little areas and adding them all together. And now we're talking about volume. Oh, I do need a visual aid here. Hold on. Let's see what I can do. So I pull out my quarters. All right. So we do still use area when we talk about volume. All right, there we go. So how do we get volume? Well, I will talk about this in just a second, but you know, for volume, to get volume, like here I have a stack of quarters, okay? And so big stack of quarters, and volume is, you know, how much would fill this up, right? Well, to fill it up, it really just comes from, hey, what shape is this? It's a circle, right? It's pretty thin, all right? And one of them is just a plain figure. And I can find the area of that circle. And, well, if I stack another one on top of it, now I just created volume, okay? And if I keep stacking, well, I've got all these areas, and you can imagine that if I keep adding all these areas up, eventually I'm going to get a big old stack of them, and I create a volume shape, right? And so this is how we get volume. Now, these, of course, have thickness, okay? But that's calculus, the difference between the two. To figure out the volume of something, all we need to do is know the volume of the base and then multiply it by how many there are, okay? Or the height, in other words, all right? And so that is how we find out the volume of any prism or cylinder. If we know the base, we find the area of the base, and then we multiply it by how tall it is. And that's going to give us the volume, all right? And so all of these, all we really have to do is this same formula right here, where it says all other prisms, really, it's all prisms and cylinders, is this formula. The volume equals capital B times H. Capital B is the area of the base. And then it's times the height between those two bases. If you'll remember, we talked about prisms having two bases. And so area of the base times the height between those bases, and that's going to get you the volume every single time. All right? It's just stacking up all those little areas. And eventually it goes to volume, okay? It works the same here. She uses a different formula. She uses length times width times height, but it's absolutely the same thing. So when I look here, I'm going to use the same formula, which is capital B times H, area of the base times the height. Well, the base here on this rectangular prism, here is the base in yellow. There's also the matching base on top. All right, remember a prism has two congruent bases, and I'm going to find the area of the base. Well, what shape is the base? Rectangle, yeah. And how do we find the area of that base? How do we find the area of a rectangle? Base times height, or length times width, whatever we want to say. The edge times edge. How's that? I like that. Edge times edge. So 9 times 17, and 9 times 17, I don't know what that is. 9 times 17 is 153. And then the volume is just that area of the base times the height between the bases, which is 24. Now, could you just do 9 times 17 times 24? Yeah, it's absolutely the same thing. Length times width times height. You can do whichever one you want. But again, one formula works for everything, 3672 centimeters squared. Area of the base times the height works for everything, all right? No separate formula needed, okay? So you can use whatever one you want. How would you do number 2? Big base. All right, big base would be 10 times 14. And then, I don't know what that is, but 10 times 14, and then times the height, 4.5. Okay. Oh, 10 times 14 is 140. Times 4.5, 630 inches squared. Oh, cubed. I'm not in area anymore. I'm in volume. Volume is inches cubed. That's right. Cubic inches. That's a measurement that fills up a space. Little 33,672 little centimeter cubes would fit inside this figure. All right. All right. So length times width times height you can totally use, or just big B times height, which we're going to get more practice on here. So looking at all other prisms, again, we want to find the volume, and volume is area of the base times the height between bases. So when I look at this figure, what is the base? The triangles, yeah. So we have the bottom triangle here, which has all these little dotted lines for us, and then there's the top one, the very top. I'm just going to outline it. But again, volume is area of the base times the height. So I want to find the area of that yellow base. Well, it's a triangle. How do you find the area of the triangle? 1/2 little base times height. All right. So 1/2 little base times height. What is the base of that triangle? 9. Not 9, actually. 12 is correct. So this, remember, we always want to look for that right angle in there. Base, little base, and height have to be perpendicular. So it's pretty easy to see that 7.3 is the height of the triangle. And the base is, again, the thing that right angle touches, which is this edge over here. And that lines up with the 12 above here. They are talking about the same length there. So 1/2, 12 times 7.3. So 0.5 times 12 times 7.3 is 43.8. And then, now that I know that that base is 43.8, the big base there, what's the height? 5. The height between those triangle bases is 5. All right. So we have 43.8 for the big base times the height of 5. And what does that give us? 219 feet cubed. There's a couple of ways you could do this work. I think, well, it was, so I did this with my 8th graders also, like they just finished this unit. I know, right? And it's like identical. It's unbelievable to me, but a couple ways you can think about it. So we know that the area of a rectangle is base times height. We know that the area of a triangle is 1/2 base times height. Let's see, what other ones we need? Area of a trapezoid? What's the area formula for a trapezoid? Yeah, base 1 plus base 2. 1/2 the height times base 1 plus base 2. And we also have the area of a circle, which we'll do on the next page. So one thing that you can do is say, hey, pick your base. Pick your base, your big base. And so like when I look at this one, I know volume is big base times the height between the bases. And what we can do is say, hey, in this figure, what's the base? I'm sorry, on number 5, what shape is the base? Triangle, yeah. And so we have this triangle shape. That is the base. There's a matching one on the back side there. And so we know that that base is a triangle. So you could just insert your triangle formula. All right, once you figure out your base, just plug it in. 1/2 base times height. You just don't want to confuse yourself because there's a lot of B's and a lot of H's. So that is one way to think about it, that you know that it's a triangle. Okay. So what is, let's see, 1/2, what is your base and your height there? 11. 11 is the base and 5.4 is the height of that triangle. 5.4. And then what is the height between the bases? 16. Yeah, that height between the bases, between your two matching bases, is 16. And that's probably the hardest part. There's lots of ways to think about how you want to do this, but it's really, you know, put in your base formula once you figure out the bases. 1/2 times 11 times 5.4 times 16. 475.2 millimeters cubed. All right, on number 6, what shape is the base? Trapezoid. We have two congruent, yeah, again, don't confuse yourself with what's on the bottom. That's not what base means. Base means, when we're talking about a prism, there are two congruent bases, okay? So the trapezoid on front and the trapezoid on back are the two shapes that are congruent. Those are the shapes that get stacked on top of one another, okay? It's trapezoids stacked up to create this figure. And so if I want to find the area of the base, we're going to use our trapezoid formula. All right, so there's our base is a trapezoid. 1/2, the height of the, what's the height of the trapezoid? 17.9. And then base 1 and base 2. What base? I got a 14. That's an easy one to see. What's this base? Yeah, it matches the 36. I'll think about that a little bit. So there's our base area. So 1/2 times 17.9 times 14 plus 36. I get 447.5. And then if I want volume, it is that area of the base, 447.5, times the height. What's the height between the bases? Yeah, and again, that's the height between the bases, the distance between the bases. So times that by 25, and you're good to go. 11187.5 meters cubed. My black is dying. All right, do you have questions on that? Area of the base times the height. Can you handle it? All right, pick your base. Well, match up your base, whatever it is. So 7 and 8 come straight from Delta Math, which you can probably tell. I popped those in there. The hexagonal prism below has a base area of 26.4 units squared. The volume is 316.8 units cubed. Find the height. What do you suppose we need to do? Basic algebra. Yeah, we have a formula. It's a prism, and our formula is volume equals area of the base times the height. And they told us the base area is 26.4, so that's going to go in for the base area. The volume is 316.8, so we're going to put that in for volume, and that's going to allow us to solve for height. So 316.8 equals 26.4 in place of that base area times the height. How do you get the height by itself? Divide off 26.4. Doot, doot. All right, so 316.8 divided by 26.4. Oh, look at that. Perfect. So the height is 12, and these would be units because they didn't specify what the units are. Number 8, the triangular prism below has a height of 10 units, so that's a height of 10 units and a volume of 331 units cubed. Find the area of its bases. All right, so volume equals area of the base times the height. We're just going to plug in what we know. The volume was 331. We want to find the area of one of the bases, and the height is 10. So we're plugging in 10 for the height, and just divide by 10. Good. So the base is 33.1 units squared. But, I'm not really going to care about that. All right, I do have a thing mentioning about oblique cylinders and cylinders. It doesn't matter. So I have this is why I have a stack of coins today. My stack of quarters. So this is the shape of a cylinder. And so we're going to talk sort of at the same time here about cylinders and oblique cylinders. Oblique just means, hey, I took this cylinder and I pushed it to the side. And so if I take my cylinder, and you can't really see from your perspective there, but, if I take my cylinder and push it to the side, has the volume changed at all? No, it's just adjusted a little bit, right? But it still maintains the same exact height that it started with. It's just slid over, but the amount of coins that I have and the volume hasn't changed. It's just adapted, okay? And so this is actually called Cavaliere's principle, in that if I want to find the volume of an oblique cylinder, it is still the exact same thing. Area of the base times the height, as long as we all understand that height is perpendicular, okay? And so when I have this formula here, we have a formula popped in, but it is still simply area of the base times the height. The difference is, what shape is our base on a cylinder? A circle. We got a circle on the bottom and a circle on top. Those are our two bases. Area of one base. Well, what's the formula for area of a circle? Pi radius squared. And so that's all they did, was they took the exact same formula, area of the base times the height, and we just went ahead and plugged in pi r squared for area of the base, since it is a circle. And so this is definitely knowing your area of a circle, good to know. And so when I look at number 10, excuse me, what is the radius on number 10? 5.5, half of 11. And then what is the height? What is the height between bases? 21. And so if I want the volume, it is simply pi times radius squared times the height. And that's all you got to write down, pi times radius squared times the height, and you're good to go. My calculator, I've got pi times, oops, not 2, but 5.5 squared times, not plus, times 21. And I get 1995. Excellent year.
I remember that year. Twilight year. Great year.
We're going to round it to 7 meters cubed. Okie dokie. Questions on that one? Last one here, back to oblique cylinders. What's our radius?
8.
8. So the radius is 8. And what's our height? 10. Don't be confused. This 10 is the height. 11 is what we would call a slant height because it's slanty. All right? It's not perpendicular. Heights are always perpendicular to their bases. And so be careful that you understand. You need the height, you need that vertical height, not the slanty height. So volume is pi times radius squared times the height of 10. Round to the nearest tenth, it says. So pi times radius squared times height. And we get 2010.6. Another great year. What happened in 2010?
I was very conscious.
Oh, it was a terrible year. I just remembered.
What happened?
I had a baby. Life as you know it was over. I'm no longer sleeping ever.